Alright, so these are our two parent graphs. I would suggest writing these down on your handout or in your notes because you are going to need to refer back to these. So, notice, kind of like what we were saying, B, if you don't remember, is called your base. Okay? And so on this first one, our B is bigger than 1, like our 2 was. So it's going to go up to the right. On our second one, our B is a fraction that is in between 0 and 1, like our 1/2 was. And so that's why it goes down as we go to the right. What is our domain for these graphs? So our x-axis. All of them. Yeah, we can be all of the x's. Can we be all of the y values? No. Where do our y values stack? So they go up forever. So where do they stop?
0.
At 0. Can it be 0?
No.
Why not? Because we have a asymptote at 0. So that means that it gets a parentheses. Because remember, that means that it cannot equal. Okay. Also notice, if I plug in a number, we're plugging it into our exponent, because our variables are our exponent, which is why it's called an exponent, because it's in your exponent. So if I plug in 0, anything to the 0 power is 1, which is why notice we have 0, 1 on both of our graphs. Then if I have anything to the first power, we just get that thing, yes? Which is why we have 1 comma b on both of our graphs as well. But if b is greater than 1, that's why it goes up that way. And when it is less than 1, that's why we are going back down. So let's look at an example. Here we have 3 to the x this time instead. So the 3 main points that we always want to try to use are -1, 0, and 1. So we already said when we plug in 0, what are we always going to get? 1. When I plug in 1, I'm just going to get whatever my base is. So in this case, that's 3. Are we all with me there? Then we have to decide, what does a negative do in our exponent? It does. So we're going to get a 1/3. So we really only need those 3 points because we know that if we are going up on the right, okay, it's just going to get steeper and steeper and steeper. So I only need that 1 point. And then on the left, it's going to get closer and closer and closer to 0. Because as, right, I make this more and more negative, this would be a 1/9. This would be a 1/27, and so forth, right? So we're going to get a bigger and bigger denominator, which makes it a smaller and smaller fraction. So that's why it gets smaller and smaller and smaller. Questions on that? So let's look at one with a small base, like 1/3 instead. So again, our three numbers that we want to plug in are -1, 0, and 1. So I still get 1 when I plug in 0. This time my base is 1/3, so I get 1/3 when we plug in 1. But now when we put a negative in our exponent, if I already have a fraction, what's that going to do to it? It's going to still flip it, but I already have a fraction. So when it flips it, it makes it a whole number, which is why it gets bigger on the left and smaller on the right. What questions do we have there? Now, those are our parent functions. Is that all we ever do with our functions? No, what else do we do to them? Do you remember? Can we move them up and down and left and right? And make them bigger and smaller? All of our transformations. Okay. These should look pretty familiar because they're A's, H's, and K's, which is what we did with our other ones. So remember that our H's, which in this case are in the exponent, are going to move it left and right, and it is the opposite sign. And your K's are on the outside, and it's going to move it the same sign. And then our A's are on the front, and that's what's going to stretch it or compress it.
Any questions?
Alright, let's look at an example. Question?
I can't read what that is at the end. A,
Plus
D-
K,
Oh, plus it. Okay, so that's it.
and the K is what moves it up and down. So, let's look at an example. We got all the things. We got an A, an H, and a K. Now, be careful, because notice we have an exponent, and our order of operation says that we have to do exponents before we can do multiplication. Yes? But if my exponent is an x, can I do my exponent? No, which means that we are not allowed to do our multiplication. So I cannot multiply the 2 and the 1/4 until we've taken care of the exponent. Are y'all with me there? Okay, so we're going to look at just the base first. What's our base? 1/4. So I'm just going to look at a 1/4 to the x. And what did we say that our three key points are?
-1, 0, and 1.
Cool. And I'm always going to get 1 for our 0. I get whatever my base is for 1. And then what are we going to get for -1 in this case? 4. So by plugging these in, I have taken care of the exponent, right? Because I had to plug those into the exponent. So then, if I want to look at my 2 next, now we are allowed to multiply. And we're going to multiply it to the outputs that we got. So 4 times 2 gives us 8. 1 times 2 gives us 2. And 1/4 times 2 gives us 1/2. Yeah. So then I'm going to graph those. So -1, 8 is going to be like way up there. 0, 2, and 1, 1/2. Okay. So that's going to be the general shape. But then we still have 2 other things. What is our +2 in the exponent doing? We said if it's in the exponent, it moves it which way? It's the flipped sign, yes, so it moves it the opposite direction of the sign.
Reflex.
Doesn't reflect it. That would be if we had a negative in the front. But it's with my x, yes? X is which direction? Horizontal, yes? So it's going to move it left or right, but because it's a +2, we said it moves it the opposite direction of the sign. So left 2, yes? And then my -3 is not with the x, agreed? So it's going to move it up and down, and it moves it the same direction as the sign, so it's going to move it down 3. So I'm moving left 2, down 3. But if I moved everything down 3, what did that also move down 3? The asymptote. So now instead of at 0, what's it at? -3. So now our graph is going to get closer and closer to -3. So that means that the asymptote is at y equals -3. So what's our domain? Is it still the same? All the numbers? Is our range still the same though? So my y values. Do my y values still stop at 0? No, this time they stop at -3 to infinity. Yes, number. Yeah.
On the green graph, like at the very top, where did you get the point right there?
So I knew that this was from, my second point here is from 2, yes, and this is at 8, yes, so I knew that my second point was like 6 above it, so I knew that the second point here that I graphed was like my 2, right, but I shifted it over and down, so then I still know that this graph, because it has to be the same shape, had to be 6 above where that one was. Normally, if I would have a better graph where you would just do left 2, down 3 from all of the points. But that was how I picked it. Yeah. Yes. Alright, other questions?